Hi guys again, how are you? Now I'm going to talk to you about the properties of logarithms. First of all, I have to correct something I did in the previous video, and it's that same as the same as I said that with the natural logarithm, we don't need to write the base because we already assume that it's e the base. For common logarithms, we don't write anything here either. Okay, if you see log and there's no base, it's a common logarithm, base 10. Okay, so I'm going to remove it here and I'm going to remove it here. Okay, so once again, if you don't see any base down here, it's base 10. If you see natural logarithm, base e. Okay, great. So now I'm going to start with the properties of logarithms. Let's start down here. 10.2 properties of logarithms. Okay, so let's start. There are 7 properties, if I'm not mistaken. I think there are 7 properties, and there's a condition that I'm going to write for all of them. If you guys remember when we were learning in the second bimester, I think, about exponents and radicals, I would, before writing each one of the properties, I would say, okay, for a larger than 0 and for whatever. Okay, so it's the same here. This condition works for all of them, and it's like this. For any positive real numbers x, y, and b, okay, b different from 1, and for any real number r. Okay, you don't need to know this by heart, but it's just I need to be strict with the math statements, so I need to write this so all the properties I'm going to talk about now are properly described. Okay, so that's all. Okay, so that stands for all the properties. Okay, so let's start. I'm not going to follow the same order as in the book. I'm taking all these properties from the book, but I'm going to do that in a different order because I think it's more intuitive in a different order. So I'm starting with the logarithmic property of 1. Logarithmic property of 1. What does this property say? This one says that for any logarithm base b of 1 is 0. Okay, that makes sense because the logarithm, as I explained in the previous video, is the number to which I need to raise the base in order to get this one. Okay, so which is the exponent I need to put over that b in order to get a 1? 0. Okay, regardless of the base, if I want to obtain a 1, the exponent I need is a 0, always. Okay, so let's write a couple of examples here. For example, let's say logarithm base 2 of 1. Which number do I have to raise 2 in order to get a 1? 0. Right? So same thing if I use common logarithms. Logarithm base 10 of 1. Which is the exponent I need to put on the 10 in order to get a 1? 0. Same thing. Okay? That's the logarithmic property of 1. Okay. Second thing, it's the product property of logarithms. Let's say, let's call it product property alone. Okay, what does this property say? It's going to be weird in the beginning, but then you're going to understand it actually relates to other things we learned previously this year. Okay, and this property says that the logarithm base b of x times y. Okay, I'm going to write a multiplication sign here just to make it clearer, but the logarithm base b of x times y equals logarithm base b of x plus the logarithm base b of y. This means that the logarithm of a product equals the addition of the logarithms. Okay? This actually relates to the point that if I'm multiplying, this actually comes from here. If I have, you know that I have x squared times x cubed equals x raised to the power of 2 plus 3, right? So this property comes from here. Okay, that's the origin of that property. But let's solve a couple of examples here. Well, actually, I think I can leave that here. Let's solve a couple of examples. So the logarithm base, let's say, logarithm base 2 of 8 times 16, for example. Really, what I'm going to do is I'm solving it in two ways so you guys realize it's actually the same result that you're going to obtain. Okay, so in this case, calculator, okay, 8 times 16, 128. Okay, that's 2 raised to the 7th power. So this is the same as logarithm base 2 of 128. Okay, so the logarithm base 2 of 128 is 7 because 2 raised to the 7th power is 128. Okay, now let's solve this but using the property. If we use the property, we would say that the logarithm base 2 of 8, we would say this logarithm actually, let's write it like this. This is the same as the logarithm base 2 of 8 as the logarithm base 2 of 16. The logarithm base 2 of 8 equals 3. The logarithm base 2 of 16 equals 4. So indeed, this is 7. So we get the same result. What do you need to remember from this? The logarithm of a product is equals the addition of the individual logarithms. Okay? And that's a product property. Closely related to this one comes the quotient property. Okay, quotient property states that, let me insert this. Okay, quotient property states that the logarithm base b of a quotient, which is going to be x, y, this parenthesis is not necessary. You will see that in your book that it's not necessary, but I like writing it. Okay, it makes things clearer, I think, because if not, this y can get mixed with the base, and it gets very close, and it can be confusing now at the beginning that you guys still are not that familiar yet with logarithms. So I'm going to write this parenthesis even though they're not necessary. So the quotient property says that the logarithm of a quotient is the difference of the individual logarithms. Okay, so this is equals logarithm base b of x minus logarithm base b of y. Okay, so actually it's the same concept. This is the same thing as I did here. Okay, if I have x squared times x raised to the power of minus 3, I could subtract these two things here, or I could do this two. I could say this is x squared over x. Okay, so this property comes from here. Okay, that's why we relate a quotient with a subtraction. So property here, actually, I think, guys, I'm going to highlight this in gray. I think it might help. Okay, so same thing as before. Let's solve an example. Let's solve an example here. So for example, let's say the logarithm, let's use base 3 now. Logarithm base 3 of, and here's a quotient, logarithm base 3 of 81 over 27 equals the same thing. Let's solve it like this. I know that's the same as saying the logarithm base 3 of 81 divided by 27, which is 3. Okay, so yeah, so the logarithm base 3 of 3 is 1. Okay, because this 3, if I raise it to the first power, I'm going to get a 3. Actually, let me use 9 here because it's going to make more sense. It's going to be correct anyway, but I think it's more illustrative this way. So this is going to be logarithm base 3 of 81 divided by 9, which is 9. The same as logarithm base 3 of 9. This is the same as saying 2. Okay? And if we apply the property, we're going to say that the logarithm base 3 of this quotient is going to be, that's going to be the difference, the subtraction of the logarithm base 3 of 81 minus the logarithm base 3 of 9. And this is going to give me logarithm base 3 of 81 is 4 minus the logarithm base 3 of 9, which is 2. And this indeed equals 2, which is giving us exactly the same result as before. Okay, and that's the quotient property. I'm going to highlight this one as well. Now let's go with the next property. We talked about the property of one, product property, quotient property. The next one, would be power property. The power property. Okay. In this case, the property says that the logarithm base b of x raised to the power of r equals r times the logarithm base b of x. Actually, the only thing that this property is saying is that if here in this number I want to get, I have an exponent, I have to take, or I can take, usually it makes my life easier. If I do that, it makes my life easier. You will see that. It says that when I have that number with an exponent, I can take that exponent out of that. And I can put it at the beginning of the expression, multiplying. Okay, it can be counterintuitive at this point, but you will see, guys, that it actually makes my life easier. Okay, and it's going to be very easy to understand if I use an example here. I didn't want to highlight this. So let's say the logarithm of, let's say the common logarithm base 10 of 1000. I can say here this is actually the common logarithm of 10 raised to the third power, right? And this is the same as saying 3. Let's do it like in the previous ones. We solve it in both ways. So this is 3. Okay. And down here I'm going to say the logarithm, common logarithm of 1000 is the same as the logarithm of 10 raised to the third power. And this is the same as 3 times the common logarithm of 10. Okay? And here you know that the common logarithm of 10 is 1. Why? Because there's a 10 down here. Okay, so this is going to be 3 times 1, which is the same as saying 3. Okay, let's do it with a power of 2, like before. Okay, let's use, as we said before, as we used before, logarithm base 2 of 120. Okay, this is the same as saying logarithm base 2 of 2 raised to the 7th power. Okay, this is the same as writing 7 times the logarithm base 2 of 2. So 7.1 equals 7. Okay, this one, it can, like, with the examples I just used, it can make you wonder, so why do we need this? Like, it's pretty obvious. Like, actually it's shorter to do it like this than doing it like this. Okay, it gets helpful when I have variables. Okay, so instead of having logarithm base 2 of 2 raised to the 7th power, I have logarithm base 2 of 2 raised to the power of x, for example. Okay, actually this is going to be the main use here. If I say logarithm base 2 of 2 raised to the power of x, okay? In this case, this is the same as saying x times logarithm base 2 of 2, okay? And that's going to help me solve things, solve equations and everything. Okay, that's all with the power property. So now we already talked about the property of one, product property, quotient property, and power property. So let's go with the last three ones. Okay, the next one I think should be the one-to-one property, which I think it's actually quite quite logical once you think of it. And it says that if logarithm base b of x equals logarithm base b of y, then x equals y. Okay, and this is going to be very useful for us to solve equations. Actually, I like the examples that you can find in your book for this one. There's an example that says if, let's say, logarithm base 2 of 3x minus 2 equals logarithm base 2 of x plus 4. Then 3x minus 2 equals x plus 4. Okay, knowing about this property can allow us to get rid of logarithms at some point. Okay, so we can just solve this equation. Okay, great. So that's with the one-to-one property of logarithms. Let's continue with the change of base formula. Change of base formula. Okay, this one can be helpful. For example, if I say this one can let me do things without using the calculator, for example. So let me write this. Okay, so for example, sorry, let's say I have logarithm base 1000 or 100 of 1000. Okay, it's not a common logarithm, it's not base 10. It's the logarithm base 100 of 1000. You can, if you think about it for a moment, it's not that intuitive. Like if this was a 10 down here, it's easy because 10 cubed is 1000. Sorry, but it's not like that. It's what's the exponent of 100 if I want to get 1000? Okay, there's a formula for this. It's a change of base. Okay, I'm going to change that into a logarithm, a common logarithm with base 10. So the property says that this is the same as the quotient, the following quotient. It's the logarithm base 10, so the common logarithm of 1000 divided by the common logarithm of 100. Okay, so the common logarithm of this number here divided by the logarithm of this number here. These two should have the same base. Okay, because actually what we're doing is a change of base. We are changing the base in order to take it to one which is more common, one which is more useful, one which is easier to operate with your calculator, and so on. So in this case, if I write it like this, it gets very easy because I can write here the logarithm, the common logarithm of 1000 is 3, and the common logarithm of 100 is 2. So that's the answer. If I want to convert 100 into 1000, I have to raise it to the power of 3 over 2. Let's solve another example with another base. Okay, let's do it with logarithm base 9 of 27. Same thing. Here it's not that easy, but I'm going to change it to a base which we know better, which is base 3. Okay, so same thing. Let's write a quotient here. It's going to be logarithm base 3 of 27 divided by the logarithm base 3 of 9. So the logarithm base 3 of 27 is 3. The logarithm base 3 of 9 is 2. So same answer, 3 over 2. Okay, that's a change of base formula. And here we come with the last property. That's the inverse property of logarithms. Actually, let me correct this because I wanted this to look this way. Because for the last example, I have two cases, so I want to make it very, very clear. So this one goes here. Change of base formula. Actually, here I did not write the general expression, which you can find in your book, and it's logarithm base a of n equals the quotient of logarithm base b of n divided by logarithm base b of a. That's the general expression. And here I can move this again. Okay, so inverse property, that's the last one. The first part is easy, and the second one is a little bit more confusing, but you guys need to know. So the first one, as I said, once you think of it, it's quite intuitive. Logarithm base b of b raised to the power of x is x. As I said, this property can be a bit confusing, but you need to know it because once you are working on the homework, you need to know how to solve that kind of exercise. Okay, so this is as easy as this. If I have the common logarithm base 10 of 10 raised to the power of x, easy, right? What's the exponent I need to put on top of a 10 in order to get 10 raised to the power of x? Of course, the exponent I need here is an x. Okay, let's do it even more evident. The logarithm base 2 of 2 raised to the power of 3 equals 3, right? Very easy. And this is the last part, which I said it's not that intuitive, but you need to know it. It's what happens when I find logarithm on the exponent. It's like going one step forwards, like what, why? Okay, but you can find that, okay? You can find that in math and you need to know how this works. And you can find that in the homework. So that's the most important part. So this means that what happens if I have base raised to an exponent which is a logarithm? So when this happens, notice that always the base down here is going to be the same base as the one you have up here. So it's something kind of this logarithm up here getting cancelled out with this base here. So actually the answer is x. Okay, so it's something like this b and this logarithm up here, they cancel out, something like that. So if we work it out with an example, you will see it makes sense. But I know when you see the formula, it's a bit like, what did you just do? But let's do it with an example. For example, if I have 3 raised to the power of the logarithm base 3 of 27, this is going to be 27, okay? Because 3, the logarithm base 3 of 27 is 3. So this is going to be 3 raised to the third power. And this is going to be 27. Okay? So in this case, in this very case, I think it's even easier just learning the formula, learning this by heart, and just remember that, and you will know how to do it. Let's solve another example just to make it clear. You will find this, usually in the homework, you will find this with variables, not with numbers. That's what makes it useful, because when these things start to get mixed with variables and everything, this makes our life easier. So let's say we have something like this. We have 10 raised to the power of the logarithm base 10 of 2y plus 3. This looks very complicated, but it's as simple as 2y plus 3. And we suddenly got rid of the logarithm. So actually it's even better. Okay, so guys, that's all with the properties of logarithms. I hope it's very clear right now. Thanks for watching and see you in the next video.